11.1 is about circumference and arc length. Let's talk about circles because we're not done with them. What is your favorite circular food? There's only one right answer.
Ice cream.
Why'd you deter from your answer there, Dorian? What is your favorite type of circular food?
Bologna. Yeah, bologna. Bologna's pretty good.
It's pizza.
It's supposed to be pizza, and if it's not, you're lying. It's fine. It's pizza. So let's talk about pizza, because that's helpful here. Pie is not helpful to me, and neither is sushi. Could be helpful actually. Oh, so circumference. Well, I'm just saying it could be helpful in my. I'm illustrating something. Okay. Okay. Gosh, guys, where is the circumference on a pizza? What is the circumference on a pizza?
The crust.
The crust. Thank you. That's why sushi might actually be helpful, because sushi has like the seaweed. You know, I'm not gonna color that well. So here's what I want you to put for circumference. It's the crust of the pizza.
Really?
Yep, you're not putting it in a blank. You're just writing it above 11.1 circumference and arc length. So writing it above, right here, yep. Circumference is the crust of the pizza. Why does this matter, Mrs. Marshall? You don't have to draw a pizza. You can if you wish.
Oh, really?
I think we all know what pizzas look like, right? Circumference is the crust of the pizza. Arc length, we don't eat a pizza whole unless it's a personal pizza, but I still think I cut it up.
Unless it's a Monday.
Unless it's a Monday. But here we go. Arc length, focus. Arc length is one slice's crust. So arc length is one slice's crust. I'll just write that in. Arc length is one pizza slice's crust. So it's a part of the circumference because it's a part of the crust. So you're going to learn some things about arc length, and then we're going to start with circumference, of course. Okay, so let's bring it back. You're not writing this down in the blank yet. We haven't gotten to the blank. The only thing that's going to go in the circumference blank, right? You have a circumference of a circle. The only thing that's going to go there are the formulas. Okay, so give me a second. The circumference of a circle is the distance around the circle. It is the equivalent of a perimeter. Okay? Here's how they came to this, right? Back in the day, they had nothing to do. They didn't have TV, right? They just sat around and they did math all the time. We know this, right? Philosophers, they sat around and they debated all the time. We know this? Like in Greece? Okay.
Yeah.
So here's what one man did. He started with a circle, and he inscribed a quadrilateral, a square, if you will. And he noticed the square does not look like a circle. We all agree?
Yeah.
But the more sides that you add, the more it looks like a circle, correct? So he took the perimeter and a diameter, and he came up and he figured out about pi, which is going to underline in 2.5 seconds. No, it will not. Pi. So go ahead and write down that pi is equivalent to 3.14.
Can we write that in the...
Just write it anywhere you want. I wouldn't write it in the circumference formula. Not yet. Pi is 3.14. So in a non-COVID year, we would have had a Pi Day. Does anybody know when Pi Day is?
What we eat pie?
March 14th. We would have all brought in a circular food, and I would have shown you how pi exists. What you do to find pi, 3.14, is it is equal to the circumference divided, you don't have to know this, by the diameter. This is how they derive the formulas. It comes from this. If you literally take any circle, so this circle right here, what you would do, remember that circumference is the length around something. You can't exactly take a ruler and measure a circle, right? So you would take something like a string, this is the best I got, and you would measure, no, it would help, so hold that side. And you would measure all the way around the circle, which is actually perfect. I'm pretty sure this is perfect. You would measure, and then you would lay it out, and you would measure the circumference, and then you would measure, okay. You would measure the diameter, and you divide them, and guess what they equal? 3.1415, blah, blah. So you would have taken your cookies and your pizzas and your donuts and your Ritz crackers, and you would have measured, and you would have measured, and you would have all found that they are 3.14 or about 3.14, because not all food is a perfect circle, right? We try, but, pizzas aren't always beautiful, but they taste delicious. So that's where 3.14 comes up. If nobody decided, let's make life difficult for teenagers and pick a letter and make it represent a number. That's not how that works, okay? It actually is what makes a circle, every single circle. That make sense? So, here's why it matters to you. You're going to write down the two formulas now. They took this, circumference divided by diameter, and they morphed it to where we could find the circumference. Circumference equals pi times the diameter. That's the first one you're going to write in. Circumference equals pi times the diameter. And again, it comes from this formula. All you have to do is multiply by the diameter on both sides, and that's how you get the circumference, right? You can also write it in terms of the radius. What do we know about the radius in comparison to the diameter? Radius is half. So if we double the radius, so the circumference could also equal 2 times pi times the radius. Because what is 2 times the radius? The diameter. So 2 times the radius is the same as the diameter. So you can use, these are equivalent to each other. You can use whichever formula as long as, it's helpful. If you're looking for the diameter or you have the diameter, use the diameter formula. If you're looking for the radius or you have the radius, use the radius formula. Here's the prettier way to look at them.
If you're just given the radius and you multiply the radius by 2, then can you use the diameter?
Use diameter formula, yeah. You're just doing a little bit in your head. I can tell you why the radius is at the back end. You would never say, you say 4x if you had a 4x, right? You wouldn't say x4 because that looks weird. That's why this r, even though it's 2 times r is the letter, pi represents a number, right? So it's just, we don't like it, but that's the formula. So the last thing to note is if you see the word exact. In number 3, the third box, I think the bottom left, go ahead and highlight the word exact. You will like when you see the word exact. It means leave it in pi form. So number 3, it says exact. Leave it in pi form. You will not multiply by 3.14. You would literally say 3 pi, 6 pi, 7 pi. Or in this case, this is pi divided by 2. Also to note, whenever you are multiplying and it doesn't say exact, but you actually multiply, in scientific calculators there is a pi button. I know this, you know this. Maybe you don't, but you should. I will know if you are using a scientific calculator at home and using the pi button. Your answer will be different than mine because yours won't be rounded, but mine will be. Because I will multiply, you and I will have 4 function calculators. We'll multiply by 3.14, and then we'll end up rounding. Does that make sense? So make sure if you're outside this class, you're using 3.14 still. Okay? And then the last thing is, unless instructed otherwise, you are always going to round to the hundredths place. So always round to the hundredths place, because 3.14, which is what we're all multiplying by, is also rounded to the hundredths place. That make sense? So just keep it uniform. Are we all good? Unless it says exact, in which life is easy. So let's do some examples. Find the circumference of a circle with a diameter of 5 inches. So which circumference formula am I going to use here? Pi times the diameter. Good. So where am I going to plug in 5?
D.
Yeah, letter D. So C equals pi times 5. So again, if you ever saw, and it doesn't say it, but if it ever said exact, you would literally say 5 pi and you would leave it there. Here it does not say exact, so we are going to actually multiply and round to the hundredths place. So go ahead and multiply 3.14 times 5. 15.7, and we would say inches. This makes sense because the circumference should be bigger than the diameter, right? I told you that pi is equal to the circumference over the diameter. What is the circumference? 3.14. What is the circumference? We said 0.7. And then the diameter we found was 5. So this makes sense because they equal pi. Okay, so your circumference should always be bigger than your diameter every single time. All right, the next one, we want to find the diameter with a circumference of 17 feet. So which formula are we going to use? Circumference equals pi times d. So where am I going to plug in 17? C. 17 equals pi d. So what is pi doing to the diameter? Multiplying, right? So what's the opposite of multiplying? Dividing. So go ahead and divide. 17 divided by 3.14, which is 5 point. Okay, 5.41, and it is feet. All right, number 3, we like this one. It says find the exact circumference. We're not really going to end up multiplying in our calculator, not unless you don't know how to multiply times 2. It says the circumference of a circle with a radius of 11 inches. So which circumference formula are we going to use? 2 pi r. So find the exact circumference. We don't know it. So the radius is 11. So you're going to multiply the two numbers together. 2 times 11 is 22, and it would be pi inches. If you don't have pi, which is the most common thing people forget, you are super wrong. Think about the difference. If you don't have pi, you would have 22. So think about 22. You have $22, right? But what is, approximately, what is 22 times pi? It's 22 times 3 something, right? So, which would be in the 60s. So $69 is very different than $22. Are we right? So make sure you have pi there because it represents multiplying times 3.14. Okay? Number 4, find the radius. So we're using the same formula one more time. C equals 2 pi r. Where am I going to plug in 4? For C, 4 equals 2 pi r. This is where you can kind of differ. When I was in school, what we just did is we learned what 2 pi was. If pi is 3.14, what is double of 3.14? 6.28. So in my school, we memorized this. You can. It's the same. 4 divided by 6.28. You could, in this case, also reduce. If this said 4 over 2x, what would that reduce to? 4 over 2x. I wrote it right here. 4 over 2x would reduce to? 2 over x, right? 2 goes into 2 once, 2 goes into 4 twice. So this could be equivalent to 2 over pi. It's the same thing. Do we see how? So either way, what do we get as our final answer? 0.64 and then millimeters. Which makes sense because my circumference was small. My circumference was 4. So the radius is 0.64. How are we doing? We feeling good? You're not feeling good? What'd you get? The dividing by 2 pi? So 2 pi is 2 times 3.14. So if you double 3.14, double of 3 is 6, double of 14 is 28. So when you divide, you do 4 divided by 6.28. I just didn't write it like that so that people wouldn't think I wasn't doing something not on both sides. I am doing this on both sides, just written in a way you could type it in. And then I said, or you could reduce it. I used x as an example just to kind of show you. You can use the same reducing methods. Yeah, no. 4 is the circumference. Okay, so now we're going to talk about arc length. Arc length is a portion of the circumference. So will arc length be smaller or bigger than the circumference? It will be smaller every single time. So here's what we end up doing. We take everything we know about a circle. What are some good things number things we know about a circle? We know about the circumference. What else do we know? It's 360 degrees. So what we can do is use a proportion of the length, the circumference, and set it equal to the degrees. So here is what that looks like, but you're not going to write it down like this. I'm actually going to write down something slightly different. You're going to take the arc length, so go ahead and write that one down. There is a box. You're going to take the arc length, which is a portion of the circumference, right? It's part of the circumference. You're going to put it over the whole circumference. Okay, so notice this fraction, all of it, length and circumference, they're both in length. So make sure I would note that. They're not in degrees, they're not angles, they're not arcs, not arc degrees. They're lengths, meaning yards, feet, meters, centimeters, millimeters. And you're going to set it equal to the measure of this arc in degrees out of 360 degrees. So your second fraction is degrees. And then I would highlight it so you could find it at a later date. So the arc length out of the circumference, so part of the circumference out of the whole circumference, equals part of the 360 out of all of the 360. Okay? You just can't deviate. Meaning you can't put length over 360. You can't put degrees in the length fraction. It's got to be length equals the degrees. Okay, so I'm actually going to copy and paste this. We're going to use this below. Okay, this one just notes arc length is always in length. So here's what that would look like. It would say that AB it would say is 6.2 inches, right? So if you ever see a length and inches or whatever outside of the circle, it is representing the length of its arc. Okay, and the last thing is arc AB is equal to its central angle. This is a central angle because where's the vertex? On the center. So if the central angle was 40 degrees, what is the measure of the arc in degrees? 40 degrees. So make sure you're deciphering the difference between length and degrees. Degrees is the amount of pivot, right, in the circle. Okay, so we're going to use it here. We're going to find the arc length, then the circumference, and then the radius. Go ahead and write down the formula while you're learning it. Arc length equals the arc over 360. All right, so the arc length is actually what we're looking for. We're finding arc length of PQ. So we don't know it. I'm actually going to put, I don't know. You could put an X. I put the letter so I know what I'm looking for because there's a lot of things happening. I'm going to put L for length because I want to. You could put X, but like on the second one, I wouldn't recommend. I'll explain when we get there. Circumference. I don't know the circumference, but I know how to find the circumference, right? What do I need to know in order to find the circumference? The diameter or the radius. And in this case, I know the diameter. So we're going to find the circumference off to the side. Which circumference formula would I use here? Pi times d. Because the diameter is 9. What is it?
28.26.
Correct. 28.26. Which means our arc length will actually be smaller than this because the circumference is all of the circle and the arc length is a portion of the circle. To figure out what portion it is, we need to find the degrees of the arc out of 360. So what is the measure of the arc in degrees? 75. Which means, the arc is 75 degrees out of 360 degrees. So think about it this way. 75 out of 360 is pretty small, right? So we're finding a very small portion of the 28.26. Okay, it's a proportion, so we can cross multiply. So we get 360L equals 28.26 times 75. 2,119.5. Good. Divide by 360. And the length is 5.89, and we'd say yards, right? Yep, yards. What'd you say? They're loud? Yeah, I'm sorry. I can't say anything or literally nothing will change, so. You could move forward if you wanted. All right, in the second, we're finding the circumference. And a lot of students struggle with knowing when to use the arc length formula and the circumference formulas. What would I need to know in this picture to use the circumference formula? The radius or the diameter. Do I know either of those? No. So that is why we have the need for the formula, for the arc length formula. Go ahead and write it in. We're going to first start with the arc length. Are we given an arc length? We're looking for the circumference. Are we given a length at all? We are given a length. What is it? Correct. It is a length. So remember, it has meters. It doesn't have a little bubble. It means that's the length of the arc it is closest to. Okay? It will never just, it would say C equals if it was the circumference, but it's not. It's the arc length. Over the circumference, which we don't know. So again, in this case, I would put C for circumference. It will help us in a second when we go to find the radius, and I'll explain when we get there. Equals the measure of the arc. What is the measure of the arc? 270 out of 360. Out of 360. So let's figure it out. We're finding the circumference. Cross multiply. 270C equals, what is 61.26 times 360? $22,053.6. Okay. Divide by 270. 81.68. And then it would be meters. All right, and then I want you to think about why this makes sense. Look at our proportion. We said 270 over 360. We said 61.26 over the circumference is equal to 270 out of 360. How much of 360 is 270? What does this reduce to? They're both divisible by 90. 3/4. So, think about this in a really remedial way. Okay? Are they equal? Did we make it equal? 6/8 is equal. 60 over 80 is equal to 3/4, right? So you want to make sure that your answer makes sense every time you do it, okay? The lengths are proportional into the degrees. Okay? This last one, there's actually 2 steps. We're finding the radius. The very reason I told you to make sure you're labeling is in this question, the radius, we're going to use the same formula. What part of the arc length formula would be helpful to know in order to find the radius? The circumference. So the first thing we are going to do, and if you want to write it, so we're first going to find the circumference, and then second, we will find the radius. And I abbreviated, and I'm sorry. First find the circumference, then we're going to find the radius. So it's helpful to make sure you're labeling the circumference as C so that you know you're not done when you get to this point when we found the circumference here. We're going to do the same process, but then one more step to find the radius. Okay, so what is the arc length in my last example? My arc length. It is 10.5 feet. Good. So arc length is 10.5. The circumference, I don't know, so I will have to find it. I'm labeling it C, so I know that this is not my final answer. And then the measure of the arc is what? Is 150 over 360. Cross multiply. We get 150C equals 10.5 times 360, which is, I missed it, 3,780? Okay. divide by 150. And the circumference equals 25.2. Okay, so we don't circle that. We found something very helpful. We know the circumference. So then what can we do to find the radius? Correct. Use the 2 pi r formula. The circumference equals 2 pi r. I know that the circumference is 25.2. So plug in 25.2 equals 2 pi r. So 2 pi is multiplying times r. So I want to divide by 2 pi. So what did we say 2 pi was equivalent to?
6.28.
Yeah, 6.28. They are the same. So divide by 6.28, and the radius is 4.01, and it is feet. Good. We have one more thing to do. And all of you are in honors. None of Sherelle's in Algebra 2. That's it, right? You're not in Algebra 2? You are also in Algebra 2, so Molly, you're going to thrive. So in math, and you will learn in Algebra 2 next year, there is this thing called the unit circle. So the unit circle is on the origin, and its radius is 1. So all of the points are at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, right? It makes a circle when you connect the dots. And it's actually not the worst circle I've drawn today, so you're welcome. So we have learned all throughout geometry and your life that there are degrees. There are angles, and we measure them in degrees, correct? Every time we use the scientific calculator, I asked you if there was a letter at the top, and if it was the letter D. What do you think the letter D stood for? Degrees. If it said the letter R, then it was in radians, which has a time and place, but just not in geometry. You will not be using a scientific calculator. I'm going to teach you how to go from degrees to radians. They are essentially both angles. One is used for everyday life, degrees. Radians are used for higher levels of math, trigonometry, pre-calculus, calculus, differential equations, which make me cry. Radians, okay? So here's what I'm going to explain about the circle. So degrees, let's start with what we know. We know degrees. We start at 0. The circle starts between quadrant 1 and 4. It's fine if you don't know what that means, but what does a 180 degree angle look like? Straight line. So a 180 degree angle is at this portion on the unit circle. Okay, so half the unit circle is 180 degrees. All of the unit circle is how many? 360. In radians, radians are written in terms of pi. So if you look, you have an example here kind of written. Pi will be in the numerator of a fraction. We'll talk about that in a second. But what's going to happen is you need to know what these are written, what the basics are, 180 and 360, what they are as radians. Okay, so 180 degrees in radians is actually pi, 1 pi. 360 degrees in radians, so if half the circle was 1 pi, the rest of the circle would be 2 pi. These are equivalents to each other. This is as far as I'll go with the unit circle. There's so much more about it, okay? But what we know is that pi and 180, they're the same. They're just written in 2 different languages, if you will. Does that make sense? Pi is in radians, 180 is in degrees. We use them to convert from degrees to radians and radians to degrees. So I'll kind of show you how we do that. And I'll explain why we do it also. So to go from degrees to radians, degrees, like 15 degrees, does not have pi, correct? We want it to have pi, and where do we want it to have pi? In the numerator. So we multiply by pi over 180. Again, I will explain why in a second. Remember that pi and 180, they're the same. Right? Just written in 2 different languages. To go from radians to degrees, I don't want pi in my answer if I'm writing in degrees, right? So in order to cancel out the pi, if in radians, pi is in the numerator, To cancel out the pi would need to be in the denominator to go into degrees, to get rid of pi, to cancel it out. Why do we do this, Ms. Marshall? I'll show you. Think about if I wanted to add these two numbers. So just go back to the basics. If I wanted to add them, can I add them as they are? No, I would have to have like denominators, right? So what would I multiply? What do I want both denominators to be first? 6. What would I have to multiply 1/2 by to make it have a denominator of 6? 3. But I don't just multiply the bottom by 3. I multiply the top by 3. So I change it into 3/6, right? Did I change the value of 1/2? No, they both represent 1/2. I multiplied the top and the bottom by the same number, essentially multiplying it times 1. That is exactly what we are doing here. Pi and 180, they're the same. They both represent a straight angle. They're just written in two different ways. Does that make sense? So what we're going to do is multiply by either one. You don't have to memorize it. I don't memorize it. Here's what I know. I'm going to go from 15 degrees into radians. Go ahead and write down 15. If I want to write in radians, I need pi in the answer. So I need pi in the numerator, and to be specific. So pi is going to be in the numerator, and 180 is going to be in the denominator. Do not reach for your calculator unless it is to reduce. You will not type in 3.14. You leave it in terms of pi. Just like the second example is already written in radians. Leave the pi there. Okay? So what we can do, you can cross-cancel. I'm recording for everyone, including standard, so I'm not going to cross-cancel. I'm just going to multiply straight across. 15 times pi is 15 pi. 1 times 180 is 180. And then all we do is reduce. Okay, so you want to look at 15 and 180. What are 15 and 180 both divisible by? They are divisible by 5. We can reduce again, though. They're both divisible by 15. If you divide by 5, that's fine. 15 divided by 5 is 3. 180 divided by 5 is a number. 36. But 3 pi over 36 reduces again, right? So what are 3 and 36 divisible by? 3. 3 goes into 3 once. 3 goes into 36 12 times. You don't write 1 pi, you just write pi. Just like we don't write 1x, we write pi. And then we write 12. Pi over 12, that's the answer. You could have cross-canceled at the beginning, but a lot of students struggle with cross-canceling. You just look across, and you see if they are both divisible by something. 15 goes into 180 12 times, so you would have ended up with the same answer. Okay? So we do the same kind of process to go from radians to degrees, except for now we start with pi. We do not want to end with pi. We want to get rid of it so that we can be in degrees. So where does pi have to be in my second fraction in order to cancel out my first pi? In the denominator. Good. You want them like this because you can cross-cancel. Again, I'm filming for everyone, so I will not. But can someone help me out? What is 4 times 180? 720. And then pi, right? And then 3 times pi is 3 pi. You got pi over pi, which cancels out. 720 divided by 3 is 240. Cross-canceling would look like the pi is canceling out. 3 goes into 180 60 times. 4 times 60 is still 240. So either way you do it, you would be fine. We have one more question to do together, and it is actually on the 3rd page. Essentially, tomorrow we start over and review it all again. So that's why the lesson kind of starts over. But we're going to do one of these today and one of them tomorrow. Find the perimeter of the shaded region. So I would just go ahead and highlight it because for some reason it didn't print shaded. For whatever reason. And we're going to round to the nearest hundredth if necessary. Hint, it is necessary. So perimeter is the distance around an object, right? It's the same as circumference. Circumference is just the circular version of it, right? So we know right now, we know this is 15, right? Do we know any other? We know the diameter of the circle, right? Does that mean that this has a length of 9? No. We do know that this is a diameter. Okay, got a diameter. What else do we know? It is the height of the rectangle, correct. What's the length of the top portion? It's 15 as well, good. So really, the only parts that we're missing are the circle, right? Essentially, there are two circles. No, it's one circle, right? It's two halves of a circle. So what we can do is find the circumference of the circle and then add it to the 15 and 15. Okay, so how would we find the circumference of the circle? What is the formula for the circumference?
C equals pi times 9.
Pi times d, which is 9, correct. So pi times 9 is?
28.26.
Correct. So that represents the circumference of the circle. Both portions of it, because if you combine them, they make, one whole circle. So what am I going to do with that 28.26? I'm going to add, right? So I want to add, let's start over for a second. I know from here to here is 15, right? So I'm going to take 15. I need to add it. You're not wrong. You're correct. You simplified it in your head. I'm also going to add the two portions of the circle. What are the two portions of the circle? What do they combine to be? 28.26, right? And then last, we still need to add in the 15. What Kevin did, and it's you can do this. What's 15 plus 15? 30. It just helps you're adding a little bit. So 30 plus 28.26 is correct. And it would be units. It doesn't say. So units. Not squared. It's not area, yeah.